Hi, my name is Alan Camou, and we're going to be doing a problem on three different types of interest: simple, compounded, and real interest rates. So the problem statement says which of the following two options will triple in amount faster. The initial value given is $5,000, and the two options are simple interest of 7%, compound interest of 5.5, compounded yearly, and then at the bottom there are two definitions. If you would like to stop the video and read them. The difference between the two interests are minor, but they result in a big difference in time. So the simple interest formula is the first one stated above. Interest equals principal rate times time. So the three variables are defined right there for you. I equals interest, P equals principal, R equals rate, and T equals time. Those are, you just plug it in to that formula, and we're looking for time in this case, so you'll have to solve for T. The second one is compounded interest. A equals P1 plus R over N to the NT. So A is the final amount you want, P is again the principal, R is the rate, N is actually the number of compounding periods per year, which changes depending on how much you compound it per year. In this case it's yearly, so it's once a year, and then T is time again, which we'll be solving for in this problem. So the solution actually goes like this. You're given a principal amount for $5,000 in both cases, two different interest rates, and two different formulas. So you have to plug in the numbers into each formula and compare the two values at the end. So for the simple interest rate, you have to take an extra step because you're trying to calculate interest and not total value. So the value start off with 5,000. You need 15,000. That would be triple. So you subtract 5,000 from 15,000, you get 10,000, and that's what you use as I. So you just plug in everything into the formula. 10,000 equals 5,000 times the rate times time. Just do simple math as shown below. Solve for T. T equals 2 over 0.7, which is the rate, 7%. Use a rate in decimal for all the interest formulas. The second one is compounded interest. Rate equals 5.5%, which is lower, but this is compounded differently, so the value may be smaller in time. So n equals 1 in this case, as explained earlier, because it's compounded yearly, so once a year. In this case, you can just plug in the things again, but it's important to note that the A value is 15,000, not 10,000, because this is A value is the total final value. So when you plug in the numbers and do the math, equals 3 equals 1.055 raised to the T. And then simple calculation, you get T equals 20.5 years. So that's how long it takes to triple from 5,000 to 15,000. Next is a comparison, visual representation for anyone who wants to see it visually. The y-axis is money, and then the x-axis is time in years. So the first one took 28 years, simple interest, to triple, and the second one took 20.5 years. So the difference is roughly 8 years, meaning the compounded one gets you more money in interest in a less amount of time. And then part B is the amount of time it will take for compounded interest with the 2% inflation. So taking inflation into account, you can calculate the real interest rate formula can be seen in the middle right there. 1 plus effective rate over 1 plus inflation rate minus 1. The inflation rate was 2%, and then the effective rate was given as 5.5 from the previous part. If you plug in both values into the equation, you can see that you get a new rate of 3.43. The new rate can be plugged back into the previous equation that on the last page, the compounded interest formula, with 3.43 being the new rate. Solving the same math as before, 15,000 divided by 5,000 equals 3, and then 1 plus the rate to the T. Take the log of both sides, and you get T equals 32.56 years. That's your answer with inflation included. So it takes roughly 12 more years with a 2% inflation. That's the end of the problem. Thanks for watching.